Hello everyone, I am a Today let's compare the screen and screen flicker performance of these three phones that are priced similarly. Regarding the screen bezels, the Nova 16 Pro is similar to the S60, while the Honor 600 Pro is even narrower than both the Vivo S60 and the Huawei Nova 16 Pro. This is the minimum screen brightness. The Nova 16 Pro is around 2.0 nits, the Honor 600 Pro is around 1.0 nits, and the S60 is around 1.1 nits. These are their color and color temperature settings. The Honor 600 Pro has an extra advanced setting, allowing adjustments to RGB and HSV color spaces, as well as screen contrast, sharpness, and other parameters. Users can freely adjust the screen colors to their personal preference. Both the Huawei Nova 16 Pro and the Honor 600 Pro have an ebook mode, while the Vivo S60 does not. Furthermore, both the Nova 16 Pro and the Honor 600 Pro offer two ebook modes, color and black and white. However, the color mode on the Nova 16 Pro is a bit strange. Are there really any books or newspapers with colors like this? The phone's color ebook mode is essentially a gamut mapping algorithm. Since paper has low contrast, low saturation, and an irregular color gamut, it is gentle on the eyes with less stimulation, reducing fatigue during long reading sessions. Therefore, the most important part of this gamut mapping algorithm is achieving paper-like color reproduction. Clearly, the Honor's colors are more accurate, and the color temperature is more natural. Huawei didn't put enough effort into this. The Honor 600 Pro and the Vivo S60 both have a sleep aid mode. By intelligently adjusting the color temperature in real time, it reduces the impact of the phone screen on sleep, helping you fall asleep more easily. I could not find this feature on the Huawei Nova 16 Pro. Within the eye protection mode, the Honor 600 Pro also has a unique feature, defocus vision relief. It simulates dot diffusion glasses and defocus glasses. Dot diffusion technology reduces the image contrast received by the retina to create a softer visual environment, alleviating overstimulation of the retina by high contrast signals. Defocus eye relief draws on the principles of optical defocus technology to alleviate transient myopia, exercise eye muscles, and make the eyes more vibrant. Now, let's look at their dimming strategies. On the Huawei Nova 16 Pro, high brightness uses 3-pulse dimming, while low brightness uses 2160 Hz pulse width modulation dimming overlay with 360 Hz thin film transistor reset. The Honor 600 Pro uses quasi-DC dimming at medium to high brightness and 3840 Hz pulse width modulation dimming with 120 Hz thin film transistor reset at low brightness. The S60 uses quasi-DC dimming at medium to high brightness and 2160 Hz pulse width modulation dimming with 120 Hz thin film transistor reset at low brightness. Let us now conduct a detailed comparison. First, let's look at medium to high brightness. We'll set them all to the same brightness level of 404 nits for comparison. At this point, the Nova 16 Pro uses 3-pulse dimming, which is screen flicker caused by the 360 Hz thin film transistor reset. The Honor 600 Pro uses 120 Hz quasi-DC dimming. As you can see, the black bars in its flicker mapping alternate between dark and light. This is because at a 60 Hz refresh rate, to ensure consistent brightness between 60 Hz and 120 Hz refresh rates, it performs 120 Hz dimming with a consistent duty cycle based on the 60 Hz TFT reset. The two black bars have different depths because the timing of the true and false resets differs. The modulation depth should be referenced by the darker one. The Vivo S60 is using 60 Hz quasi-DC dimming at this moment, and its refresh rate is also 60 Hz. When the refresh rate is 120 Hz, the Honor 600 Pro remains at 120 Hz quasi-DC dimming. The screen flicker at this point is caused by the 120 Hz thin film transistor reset. You can see that the two black bars are now equal in depth, matching the deeper one from the 60 Hz refresh rate. Now looking at the S60 at a 120 Hz refresh rate, it uses 120 Hz quasi-DC dimming with a lower flicker depth than at a 60 Hz refresh rate. To summarize, at medium to high brightness and a 60 Hz refresh rate, the Honor 600 Pro has the shallowest black bars in the flicker mapping, meaning it has the lowest modulation depth. The Nova 16 Pro and the S60 are about the same, both higher than the Honor 600 Pro. At a 120 Hz refresh rate, the black bars on the Honor 600 Pro and the S60 are similar in depth, meaning their flicker depth is about the same, and both are better than the Nova 16 Pro. Now, let's compare their flicker performance at low brightness, adjusted to the same brightness level of 21 nits for comparison. At this moment, the Nova 16 Pro is using 2160 Hz pulse width modulation dimming, overlaid with 360 Hz thin film transistor reset. These darker black bars represent the thin film transistor reset. The Honor 600 Pro uses 3040 Hz PWM dimming overlaid with 120 Hz TFT reset. The S60 uses 2160 Hz PWM dimming overlaid with 120 Hz TFT reset. Clearly, whether it is the TFT Whether it is the screen flicker at reset or the high-frequency pulse width modulation flicker, the Honor 600 Pro has a lower modulation depth than the Nova 16 Pro and the S60. The Nova 16 Pro and the S60 have similar modulation depths. This is a comparison of their color and brightness consistency at the same low brightness level.
The end of the video shows how their colors shift when viewed from an angle.
Eventually, I finally learned.
I am a factory assembly line worker. Welcome to the comment section to discuss. Bye bye.